Thank you for joining us for this information session. Today, we will be discussing the part-time graduate program in Materials, Science, and Engineering offered at the Whiting School of Engineering at Johns Hopkins University. My name is Cheryl Williams, and I am the Assistant Director of Recruitment and Marketing for the Whiting School of Engineering. With me is Dr. James Spicer. Jim is the chair of our part-time programs in Materials, Science, and Engineering. He is a professor for our full-time programs in the Department of Materials, Science, and Engineering, and a member of the principal professional staff at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. His research interests include materials characterization, laser materials interactions, materials for energy, structural materials, and optoelectronic and magnetic materials. Last, Jim is a graduate of our full-time programs, having earned his PhD in Materials, Science, and Engineering from Johns Hopkins in 1991. Jim, would you like to say hello?
Yes, good evening, everybody. I really appreciate you joining us.
All right, thank you, Jim. For tonight's presentation, we'll start off with an introduction to Johns Hopkins Engineering. Next, Jim will discuss with you our part-time degree program in Materials, Science, and Engineering. Then we'll review some helpful information on tuition and payment options, talk about next steps and important dates, and we'll end with a live question and answer session. If you have any questions at any point in the presentation, please type them into the questions tab on your control panel. If you are joining us via a cell phone or a tablet, simply select the question mark to access the questions section. We'll address all questions at the end of the presentation. So why study engineering at Johns Hopkins University? Johns Hopkins University was founded in 1876 as the nation's first research university. The School of Engineering opened its doors in 1913, and in 1915 it began offering part-time engineering coursework as night classes for technical workers. Since then, we've grown to offer more than 20 master's programs that can be completed part-time. 18 of these programs can be completed entirely online. Our programs are designed by people who thoroughly understand your industry. Our faculty are all expert engineers, and our faculty and instructional designers construct new and update existing coursework every year so that it includes the most up-to-date information. In addition to our part-time programs, the Whiting School of Engineering has over 25 research centers and institutes. This includes our strong partnership with the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. We also offer full-time bachelor's, master's, and PhD programs that are conducted in residence at our Homewood campus in Baltimore, Maryland. Our full-time and part-time programs are led by respected senior engineers from our Applied Physics Laboratory and faculty from our full-time programs. We are ranked in the top 20 best online graduate engineering programs by U.S. News and World Report. And of all the schools that are included in these rankings, we have the largest online part-time student population. So not only will you have lots of fellow students going through a similar learning experience, but these rankings really speak to the quality of our programs regardless of our size, and our school is experienced and well-equipped to help you navigate graduate education as an online student. The degree that you earn studying with us part-time is of the same quality as our full-time degree program, so your diploma will not say part-time. You are eligible and highly encouraged to participate in commencement, and as a graduate, you will be one of more than 28,000 Whiting School alumni and will join our esteemed international alumni community. So that is an overview of who we are and the value of our programs. Now Jim is going to talk to you more about materials, science, and engineering. Jim?
Yes, thank you, Cheryl. So as Cheryl told you, I'm the chair of the Material Science and Engineering program in EP, and I also advise all the master's students in our program. So if you join us, you will be able to interact directly with me, and I will guide you through choosing your courses in our program and guide you to completion during your entire time in our program. Material Science and Engineering at Hopkins. We have the EP program, and then we have the Department of Material Science and Engineering based up at Homewood, where full-time students study. And in our department, we have research that's being pursued by our faculty members in areas related to biomaterials and nanomaterials, energy-related materials. We have computational material scientists and people exploring the world of polymers, structural materials. It goes on and on. The research landscape in material science and engineering at Homewood, though, goes well beyond our department. It actually extends into different research centers and institutes like the Hopkins Extreme Materials Institute and the Institute for Nanobiotechnology, and also obviously at our Applied Physics Laboratory, where there's a very strong materials presence, and a number of our instructors are on the technical staff at the Applied Physics Laboratory. So we all are on the cutting edge of materials research and get into a lot of different areas related to materials. But I think I've been asked to talk about my research. And as Cheryl told you before, some of the areas I'm interested in are related to optical interactions with materials for materials processing and characterization. And here's an example of some work that we've been pursuing in my group for a number of years, making nanocomposite materials. It turns out that when you make some structure in a material nanoscale, that it imparts many times interesting behaviors that you couldn't get otherwise. And in this slide, I'm focusing on the optical properties of some of these polymer matrix metal reinforced nanocomposites. And what we've been able to show is that you're able to create very specific particle architectures that radically change the optical properties of these types of materials to make them more useful for applications that might be related to like water treatment or making window coverings that are self-darkening. And this is an area we've been pursuing for a while because we have a route of processing these materials that makes them scalable. Many times people make a bit of material that's 5 millimeters on edge and they characterize it and it has great properties, but they don't know how to make it by the yard. And in our laboratory, we've been pursuing how to make these specific particle architectures over large areas so that it can become an engineering material that's significant and has impact in the real world. And another area that we've been pursuing is being pursued by a lot of different government agencies, and that's namely additive manufacturing. And a lot of companies, they've been pursuing additive manufacturing. Most of the time when companies or government agencies are doing additive manufacturing where they build up a part layer by layer using laser-based sintering or some other fabrication technology, they mostly just use metals or metal alloys. And that restricts the types of materials and applications you can address. And in my laboratory, we've been working on unique methods to do reaction synthesis of ceramic materials to create non-oxide ceramics that are really important in a lot of engineering applications that you can't produce using additive manufacturing methods at this point in time. And so we've been interacting with colleagues at our Applied Physics Laboratory, trying to develop new ways of producing these non-oxide ceramics using laser-based synthesis methods in order to implement those synthesis methods in an additive manufacturing environment. So again, this is a relevant area for a lot of engineers who are working in industry, and it really is the future of a lot of areas of manufacturing. So I think that's all I have to say about the research. Talk a little bit about the students who are in our program. I was very interested to learn recently that the average age of our students in our program is 25. So it looks like people go out and they become employed, and then they realize that getting that master's degree is important for their future career development, and they join us in our Engineering for Professionals program. And as you can see, 100% of our students have some sort of employment. Most of them come from our Applied Physics Laboratory, but also from nearby companies, including Northrop Grumman. And interestingly enough, we also have some high school teachers who have decided to come back to school and get a master's in material science. They're actually chemistry teachers, and since chemistry is close to material science, they take a material science degree for a master's degree in EP because we don't have a part-time chemistry degree. And currently, we have 21 students who are actively engaged in the program taking classes. So it's a dynamic mix of people, and I've had the privilege of interacting with a number of our students directly, even though many of them take courses online. But sometimes I get to see them at various events that are held for our students, and it's always interesting to see what our students are up to at their places of employment. Within EP in material science and engineering, we have one concentration, a nanotechnology concentration, where a student can take some extra coursework and have this concentration annotated on their degree. But generally, we offer a straight-up material science and engineering degree where you get to pick from a range of electives, but we also have sets of electives that you can choose from that are focused in areas related to biotechnology or nanomaterials. So nanotechnology is the only concentration. It requires extra coursework, but you can focus your studies in either biotechnology or nanomaterials if you choose to, and we've identified a number of courses in these areas that you're able to take and get a better understanding of some of the cutting-edge topics that are in these areas. So for our degree, you have to complete 10 courses over a time span of 5 years. In material science and engineering, you're required to take 2 courses, our 2 core courses. Everybody takes them. One is structure and properties of materials. The other one is thermodynamics and kinetics of materials. And then in addition to the 2 core classes, you have to take 8 elective courses. And these courses don't necessarily have to be offered from our program. You can take materials-related courses from other programs like mechanical engineering, applied physics, applied biomedical engineering. You can also take engineering, a couple of engineering management courses, and that will count towards your degree. But there's also the option of performing a mentored research project where generally this is a 2-course sequence. So 2 of your elective courses would be this research project. And the product of your research project would be some sort of report that you would give at the end of your experience. So some of our elective courses, I was talking about the biotechnology focus before, coursework that you can take that's offered out of materials, biomaterials 2, host response and biomaterials applications, or chemical and biological properties of materials. There are other courses and other programs that you can take that would be applied towards the biotechnology focus. Again, these are listed on the website. Out of the applied biomedical engineering program, you can take biomaterials online, you can take biochemical sensors online, or you can take courses like biomechanics of cells and stem cells or physiology. You can take courses that are offered specifically up at the Homewood campus in biomedical engineering, or even in material science like tissue engineering or cellular engineering. These are all options to you. If you are able to take courses during the day, the options open up tremendously because then you have access to all the courses that are taught in the full-time program. So the nanomaterials focus, there are courses that you can take that are related to this that we've identified, like nanoparticles, micro and nanostructured materials and devices, chemistry of nanomaterials, and chemical synthesis and processing of advanced materials. All these courses are offered every year, and so generally, if you're with us for 2 years, that means you'll be able to take those. Again, you can take other materials-related courses that are related to nanomaterials outside of our program, outside of material science, such as electrical and computer engineering or applied physics, where you can take courses that are focused more on the electronic behaviors of materials, like listed here, electronic materials or nanoelectronics, physics and devices. And again, you can come up to Homewood, especially during the day, and take some of the courses that are offered there, like fundamentals of microscale phenomena, colloids and nanoparticles, and there are other courses as well. These are just some examples. Outside of the focus areas, there are other courses that you can take if you're just generally interested in materials and don't want to necessarily focus in those other areas, materials characterization, electrical, optical, and magnetic properties, physical properties, and mechanical properties, which we just offered online for the first time this past semester. additive manufacturing. And so these don't necessarily focus on the bio or nano aspects of materials, but are of broad usefulness to materials people. So these are courses that you can look to take. Again, you can take courses outside of our program, our department in materials. So here are 3 that are offered in mechanical engineering. Advanced strength of the materials, that's in the EP program. It's offered online. Modern polymeric materials, again online. And recently, ME offered symmetries of crystal and solids online. And, that course is even more materials focused than some of the courses we teach in our program, actually, because the mechanical engineers really recognize the importance of some of these hardcore topics in materials. And so they offered this course, Symmetries of Crystal and Solids, I think this past summer for the first time, and it's online. So when we talk about the focus areas, there's no notation on the transcript that you focus your studies in those areas. However, if you concentrate specifically on nanotechnology, it does get annotated on your transcript. These are the core classes that you have to take in nanotechnology. You take structure and properties of materials, thermodynamics and kinetics. Those are the 2 core classes in materials science and engineering. But then you also have to take Introduction to Nanotechnology and Nanomaterials. The Introduction to Nanotechnology was offered online for the first time this past spring semester. And the Nanomaterials course is still taught face-to-face, but we're moving that into the online environment as well. So where are the places that you can take courses? Mentioned the Applied Physics Laboratory before. It's located in Laurel, Maryland, and you can see where it's located. It's easy to get to if you're in the Baltimore, Washington metropolitan area. Courses start at a time where you can get there with minimal interruption because of rush hour, actually, which is kind of interesting. Another place that I mentioned where you can take courses is at the Homewood campus up in the middle of Baltimore. This is where all our full-time students study, but you can take any courses up at Homewood that you choose. Again, most of the courses at Homewood are taught during the day, and so you would have to find that time in order to take those courses up at Homewood. Whereas at the Applied Physics Laboratory, those are taught beginning in the early evening or later in the evening. And so more often than not, those are a better option for our students who are working full-time. So I mentioned online coursework. There are courses that we're going to be moving online. In particular, our 2 core classes, we're going to be moving into online delivery mode. Thermodynamics and kinetics of materials will be taught online for the first time in spring of 2019. And then in the fall of 2019, we'll be teaching structure and properties of materials online for the first time. And we will also be moving nanomaterials, the second course that concentrators in nanotechnology take. That will be moved online in the summer of 2019. So once these courses get all online, in theory, conceivably a student could obtain their degree in material science and engineering completely online by choosing a number of electives either inside of our program, but more often than not outside of our program in mechanical engineering or electrical and computer engineering or in applied physics. And there are already a lot of materials-related courses that are offered out of those programs. So once our core classes get online, you should be able to complete your degree program completely online if you chose to do that. New courses that we're going to be rolling out this fall, I'm really excited about these. Chemical synthesis and processing of advanced materials, and also design for additive manufacturing. Currently, we already have an introduction to additive manufacturing, but we're developing a course sequence specifically in this area of materials processing because of its importance to the future manufacturing of products from materials. And this design for additive manufacturing is the second course in our sequence, and it will be taught face-to-face or in person for the first time this fall. And to reinforce the strength of our program in areas related to materials processing, we're offering this course on chemical synthesis and processing of advanced materials for the first time this fall. And that's really an evolving focus of our program, is the processing and manufacturing of products with different materials. And an area that is not really emphasized even in our full-time program. And if you're a full-time student at Hopkins, you would take our EP courses in order to get a better understanding of these areas. Now, these courses in synthesis and processing and manufacturing are being taught by working professionals at the Applied Physics Laboratory who are leading researchers in these areas. So I'm really excited to be able to offer these courses through our program this fall. So for admissions, we're generally looking for somebody who has a bachelor's degree in some area of engineering or science, especially those areas that somehow relate to materials. So before I mentioned how one of our students who's teaching in the Montgomery High School system is a chemistry teacher. His degree is in chemistry, but that's related to materials. And obviously we get material science students coming into our program. But we also get mechanical engineers, electrical engineers, all kinds of different engineers, the physicists come into our program. And so there are a lot of different degrees in areas of science and engineering that prepare you adequately for entering our master's program. We're looking for a GPO that's better than 3, though. So you really need to make sure that your understanding of your foundational coursework in areas related to calculus and physics and chemistry is in place. And so, yeah, we're looking for strength of record in terms of overall GPA, but also strength in just your foundational coursework. That can be quite important in being successful in a degree program, because that's what we're really looking for, is we're looking for students who are going to be successful in our program, because not only do you want to be successful, we want to see you succeed. One last thing, we don't look for GRE scores, so you don't have to take the GRE in order to be accepted into the program. Also, I will say that even if your academic record is not very strong, might be borderline, we do look at your professional record. What are you doing at your workplace? We look at letters of recommendation that you might solicit from your supervisors. And this can be quite important as you enter our program, because it shows that you have a reason for entering our program beyond simply trying to develop your professional credentials, but you're trying to gain knowledge that will help you develop professionally in ways that you wouldn't be able to otherwise. So I think I'm done. Thank you
All
very
right.
much.
Thank you again, Jim. Now we'd like to share some information to help you take this next step. Some of the most common questions that our admissions team gets from prospective students is, what is the tuition and what resources are available to help me pay? So here it is. Our tuition is currently $4,250 per course. Our courses are each 3 credits, so this is the total tuition cost for each 3-credit course. Because our tuition fluctuates every year due to inflation, we encourage students to budget $45,000 total for their degree. This cost may exclude books and materials. The cost of books and materials really depends upon the coursework that you register for. But in addition to tuition, there are no fees. So our students do not pay, for example, a technology fee every semester. Our online and part-time students do not pay a student union fee or similar. We do not charge an application fee for this program. So, no fee to submit your application for admissions. The only fee that our students pay is a fee at the end of their course of study with us, known as a graduate's fee. You have a variety of financing options available to you depending on your personal circumstance. I really encourage you to investigate and to take advantage of any education benefits that your employer may offer. Just as Jim said a few moments ago, 100% of our students currently enrolled in material science are employed, and the majority of actually our students enrolled in our online and part-time programs are using some form of tuition benefit from their employer to help them pay. So contact your supervisor, reach out to your HR department, see what's available to you. We unfortunately do not have any scholarships available for our online and part-time graduate students, but there are other associations and organizations that do. For example, the National Consortium for Graduate Degrees for Minorities in Engineering, otherwise known as the National GEM Consortium, does offer fellowship programs. Rules, requirements, and application instructions can be found on GEM's website. The application for these fellowship programs is open from July 1st to November the 13th. If you are a U.S. citizen or a qualifying U.S. resident, you may be eligible to use financial aid. The financial aid that's available for graduate students is largely unsubsidized loans. So similar to that, you can of course finance your education through a personal loan. And if you are active or retired military and you have veterans benefits, you can of course utilize these to finance your education. We do have a number of active duty and retired military enrolled in our online and part-time programs. If you are planning to use veterans benefits to finance your education, here are some things to keep in mind. The URL that you see here on your screen, ep.jhu.edu/veterans, has some great information on the forms that you need to submit in order to utilize veterans benefits at Johns Hopkins. For Chapter 33 post 9/11 benefit recipients, the Department of Veterans Affairs sets an annual cap on tuition for private schools. That cap is $23,671.94, and it's for an entire academic school year. So it includes the fall, spring, and summer semester, and then renews every fall. 5 courses with us will cost you $21,250, so that is underneath the tuition cap. However, 6 courses will exceed that tuition cap. The cost for 6 courses is $25,500. Johns Hopkins is a yellow ribbon school. How yellow ribbon works at Johns Hopkins is that it is applied once that tuition cap is exceeded. And if it is exceeded, qualifying students can receive up to $1,000 per year. It's awarded on a first come, first served basis. Coming this fall, there are some changes regarding how the VA will be calculating the housing allowance for Chapter 33 recipients. BAH, your basic housing allowance, will be calculated using the zip code for your on-site classes, i.e. the physical location of the classroom utilized. We are also happy to announce that Hopkins offers various networking opportunities for our veteran students. For current students, we have an online networking group via LinkedIn. Simply search the Johns Hopkins University Veterans Connection Group or Johns Hopkins Veterans to locate that group on LinkedIn. For alumni, we have a networking group offered through our Alumni Affinity office. So simply visit alumni.jhu.edu for more information. Students who are educated outside of the U.S. do have some additional admissions requirements. They are that they must submit an international credit evaluation of any credit earned at non-U.S. institutions. We prefer that students go through WES. That's a third-party credit evaluation service for this evaluation. The product that you want to request from WES is called the ICAP. International students also must submit proof of English proficiency via, for example, qualifying scores on a TOEFL exam. Unfortunately, international students studying on an F1 student visa are not eligible to enroll in this program. Typically, international students are permitted to enroll in our programs and study online from their home country. Unfortunately, it's not possible at this time to complete the program 100% online, but just as Jim was saying earlier, stay tuned as we move more of our coursework online. You may have the opportunity to complete this program online in the near future. Next steps and important dates. If you are interested in enrolling this program, your next step is to submit your application for admissions. You can do this by visiting ep.jhu.edu/apply. After submitting your online application, you'll need to submit your academic transcripts and your professional resume. Instructions for where to send these documents can actually be found on the application website, so ep.jhu.edu/apply. The instructions are actually listed directly above the application form. We offer rolling admissions for our part-time program in material science and engineering. It typically takes our admissions department and the academic departments 4 to 6 weeks on average from the time that we receive your completed application, so your online application, your transcripts, and your resume, 4 to 6 weeks to review that packet and then issue an applicant a decision letter. So with that timeline in mind, here are some important dates. Our fall registration opens on July the 5th, and the fall semester begins on August the 27th. So if you are interested in studying with us in the fall, I encourage you to submit your application materials as soon as possible so that we have enough time to review those documents. Spring semester, plenty of time to apply for that particular semester. Registration for the spring opens October the 25th, and the spring semester begins on January the 28th. So that is the end of the prepared portion of this presentation. Now I'd like to open it up to all of you to answer any of your questions. Jim is here to answer any of the questions you may have about this program. How you can ask Jim a question is to simply type it in, select the questions tab on your control panel, and then just type your question to Jim and we'll read it aloud here. If you are joining us via a cell phone or a tablet this evening, simply select the question mark to access the questions section, and we are happy to answer any of your questions. Just to answer a question that we typically receive a lot during these presentations, and that question is, can I have a copy of the slides after the event? We have actually recorded this presentation, and we will be emailing you the URL for the recording as soon as it is posted online. So that information will be coming to you shortly. Jim, as we wait for our attendees to submit questions, maybe you can talk to us a little bit about, you know, a little bit more about that mentored research project that you mentioned earlier. Do you?
Yeah, you know, that's something that I don't think enough students take advantage of. This past year, one of our students had a mentored research experience with one of our full-time faculty members up at Homewood, Todd Huffnagel. And Professor Huffnagel's area of research is related to glassy metals, or metallic glasses as they're called. And he's been doing a lot of research in this area, and one of our EP students wanted to do a project with him over the fall and spring semester of last year, and was able to do some of the work at his place of employment, as well as meet with Professor Huffnagel through the year, and was able to get some really interesting things done. But you know, that's kind of unusual in some ways, that an EP student would identify a faculty member at Homewood who they wanted to do research with. Many times the student does the project at their place of work, and they have a mentor at their workplace who has been approved by the program to oversee the work, and then have a faculty advisor in EP who's on the faculty of EP, who is the advisor of note. So they're the person who actually submits the grades and approves any reports that are submitted. And there many more often than not, there are opportunities for students to actually identify a project that's related to their work that they're able to carry out. The only thing that has to happen is they have to be able to release the important aspects of their work publicly. So they will write a report at the end of their experience that has to be able to be disseminated widely, and can't contain, you know, proprietary information that's related to their workplace. Generally, though, that's not an obstacle that can't be overcome, that students are able to find a way of doing that. And in the past, I've actually advised a number of students who have carried out projects at their workplace. And it's really neat, because the students develop a closer interaction with faculty members, or a faculty member who might be overseeing their project, than they would otherwise just by interacting with them through a course. So it's a really neat option.
All right. Wonderful. Wonderful. Jim, let's take a couple minutes and talk about, you discussed earlier some of the courses that recently came online, and we have some courses in the pipeline to be put online as well. Why don't we take a couple minutes and kind of talk about what online study is like at Johns Hopkins?
Yeah, so it's really interesting. I think that our online instructional design team has no equal in the United States. I'll be honest with you, in that anybody who has access to one of our online courses, especially some of the newer ones or ones that have gone through a refresh cycle, would be excited to see what's happening in online instruction these days. So in the past, it might have been a narrated PowerPoint presentation, not anymore. So when we rolled out mechanical properties this past spring, the instructor was working with something that's called a light board. And this is where it's almost like being in the classroom with the instructor. And honestly, when I went through that course with the students, and I know the instructor, I felt like I was in the room with the instructor. The presence is really there, which is really neat. I know that students are concerned about the way the actual interaction occurs when you're have some sort of chat room where everybody gets together at the same time and might submit questions, or there's a discussion group. And I think that these can be really useful for engineers, even though historically in the past this might not be a way that engineers interact as part of the educational process. It certainly is the online equivalent to having some sort of discussion in the hallway at your workplace. And so there are things that I know concern students about having that interaction with the instructor that they lose by going into the online environment. But I think some of the ways that the lectures are being packaged today are really exciting, and the way forward for online instruction is even more exciting. And I'm looking forward to not only getting more of our courses online using today's technology for delivery of those courses, but also what the possibilities are out there. And what I like to discuss with our course instructional designers is how something like video games has evolved over the past 20 or 30 years. And, you look at the immersive environments that people operate in as they game today, and you can only
Absolutely.
imagine that that's the direction that online instruction might be going. And that's really exciting.
That is very exciting. And we actually received a Delta grant to explore just that, in instituting, looking at, how maybe virtual reality or other kind of similar could be incorporated into online events. So
It's really exciting, isn't it?
it's incredibly
Yeah,
exciting. The
yeah.
actual mechanics of how an online class works, our spring and our fall semesters are typically 14 weeks. Stop me if I say anything wrong, Jim, here. And typically the course content is divided into separate modules. Isn't that correct? That maybe a module
Yes.
would span a week to 2 weeks?
Well, and it depends on the course and the instructor, but certainly,
Mm-hmm.
there will, week by week, there'll be modules that the student needs to work through. And in the case of some of my instructors, they might have multiple modules where each one might be 10, 15 minutes long, and they'll have to do 4 modules or something, 5 modules in that week in order to get all the information that will be discussed at some chat room meeting. So yeah. Yeah.
Absolutely. And for the most part, while students are reviewing the material, they're doing so asynchronously. So if you are studying online, and for example, if um, you have the flexibility to review that material and kind of step through some of those exercises on your own. And then like Jim was saying, we typically host, is it once a week or is it multiple times throughout the week, live office hours with the instructor?
Yeah, again, that's up to the instructor, but at least once a week. Yeah, yeah. And you know, I think it's important to realize that yeah, you can step back through the material and rerun parts of what you might have missed the first time through, and uh, you know, with the direction that the online instruction is going, it really is like you're sitting in lecture. And unlike in a face-to-face environment where many times students are reluctant to stop the instructor and ask them to repeat themselves, uh, here in the online environment, you can ask the instructor to repeat themselves as many times as you need, and sometimes that's useful.
Absolutely, absolutely. And another thing that I'd like to point out is that these recorded lectures that are part of the modules, typically we record them in short bursts. So we encourage instructors to record them in 10, 15, 30 minutes maybe, but short chunks that you can so you don't have to wade through a long uh, lecture. It allows you to kind of quickly review that material. Is that the case also within material science?
Absolutely. And when I was talking about different modules and things like that, yeah, that's kind of the length that some of the modules were that our instructors were putting together. And, you know, I could see where somebody during their lunch break or something could go through a module quite easily. And I think it's a great way of breaking up the material. Yeah.
Absolutely, absolutely. And then another thing that I really love that some of our instructors do is the way that they actually structure, like schedule the week, the week of work, the week of class week. So in that, like a lot of instructors will end their class or start and end their class like on a Monday and a Tuesday. And what that does is that actually gives you the full weekend to work on your coursework. That way you don't have to be rushing. Maybe Sunday, the deadline is Sunday 12 a.m. Oh, what does that mean? Do I have to submit it Sunday 11:59 p.m. or Saturday 11:59 p.m.? So taking it out of the weekend and giving you kind of full command of your weekend to work on your coursework, I think is really helpful for our students who are working. Is that also true within the MSE program?
You know, I wish I knew the answer to that question. I hope that's what our instructors are doing, but I don't know.
We'll just go ahead and say that it is, because I think in my discussions with the instructional design team, that is kind of a best practice that they encourage them
That's
to
what they
do. So,
do. That sounds
yeah.
good. Yeah.
All right. All right. Well, Jim, the time is about 7:50 p.m. and I think that we have gotten to the end of our questions. Do you have any kind of parting thoughts, parting pieces of
Not at
wisdom?
all, but I will say, and but I will say that if students have questions still, that they should feel free to contact me by email or call me. My contact information is on the website, but my email address is spicer@jhu.edu. So I'm more than happy to discuss any questions they might have.
All right. All right. Well, wonderful. Well, thank you, everyone. Thank you, Jim, for your time this evening and for sharing with us all this information on your program. And thank you to you, all of our attendees, for giving us an hour of your evening. We look forward to staying in contact with you and hopefully reviewing your applications.